here is connecting the two midpoints. And this works the exact same as finding an average. So in statistics, you can find an average. An average is adding up two values and then dividing by the number that you have. Here, instead of adding up values, we're adding up sides. So we're going to add up the top base, which is 5x minus 4, and the bottom base, which is 6x minus 2. So we're going to add these two up, divide them by 2. That's going to equal 4x. So first we'll take 5x minus 4 plus 6x minus 2. Those two bases added up, divided by 2, will average out to equal 4x. Now from here, you do have a choice. You can double your mid-segment, which is 4x. So you could just make that 8x, and then that would equal exactly the two bases added together. Or you can use the average. You can divide by 2. The only thing that happens there is sometimes you get decimals, which sometimes it's not very fun to work with decimals. So what I do is I just take my two bases, 5x minus 4 plus 6x minus 2, and we're going to set that equal to 8x. We're going to double that mid-segment. So the two bases added together divided by 2 equals 4x. So if I double 4x, that would equal those two bases added together. And we just continue with the algebra. We'll kind of separate that here. We're going to get 11x minus 6 equals 8x. We will subtract 11x over, so we'll get negative x equal, or negative 6, equals negative 3x. Divide both sides by negative 3, we'll get x is equal to 2. Once you know what 2 is, you can plug 2 back in, and you'll get your results. So it looks like the top base would be 10 minus 4, which is 6. The mid segment would be 8, and then the other segment would be 10, which works because 6, 8, 10. 6 and 10, the average would be 8. So that would be your result. Then number 20, determine if the triangle is scalene, isosceles, or equilateral. So the big thing we have to do here is we have to figure out what are the lengths of the sides. And to do that, we're going to use the distance formula. So the distance formula is x minus x squared plus y minus y squared. And you should have those formulas all in your notes. You're going to want to have that distance formula handy as we get into our test tomorrow. And then take all that and square root it. If you have a line that's straight vertical or straight horizontal, we can just add in the distance. So right here, we can see that this straight vertical line is 3. This horizontal line is 1, 2, 3, 4. And then we could use Pythagorean Theorem to figure out that this hypotenuse is going to be 5. So this first one is going to be scalene. So all I did to find 5 was we could do 3 squared plus 4 squared equals c squared. So we're kind of throwing in that Pythagorean theorem because I have 2 of my sides of a right triangle. I can use Pythagorean theorem to find the third side. In that second problem, we're going to have to use those coordinates in the distance formula to find out our distances. And based on what I'm seeing, since this side right here goes down 3 over 1, and then this side over here goes over 3 down 1, these two sides are going to be exactly the same because they're crossing the exact same diagonal. And then this side would be different. So which sides are the same, which sides are different? There's 2 the same, 2 or 1 different, excuse me. That means that we're dealing with number 21 would be an isosceles triangle. So sometimes you don't even need to use the distance formula. You can just see the length follows 1 square by 3 squares, and then the other one follows 1 square by 3 squares. So they're going to go the exact same distance. And then that third side is not following that same pattern. So that would mean that that's different, which makes isosceles. All right. Well, if there's any other questions, I will, you can stick around and I will